Hello, this is Damnesia, and welcome to the first tutorial on Java. I have opened up Eclipse already. I've created a new workspace so I can start on everything. When Eclipse opens up, it'll ask you for a workspace. Now I suggest putting the workspace inside its own folder, otherwise you might get a little bit of a mess trying to find your work and stuff like that. So as you open up the workspace, the first time you open it up, before you ever use it, you'll see that that workspace has never been used, and it'll pop up this little screen. It actually used to say something here, but it doesn't seem to be doing that much anymore. I guess it's just kind of a welcome screen, so you can close this. There's no problem with closing it. What I would suggest doing now is going right over here to the right hand corner, open perspective, and then change over to Java. Right, and this is the one we'll be using. There's also a debug view, but that one opens automatically when you need it, if you ever click the debug button that you'll see in a second. Alright, now that we've got this one open, I don't really like the resource view. I'll just close it, but you can keep it if you want. I just like to minimize these, just so they don't take up too much of the screen. And this is going to be where you're going to work, and this is going to be where you open up all your projects. Those coding projects that you're going to have are all going to show up over here, and over here is where you're going to actually see the code. You can open these things in full screen by just double clicking them. You'll be able to do that with the code as well when we start. And just to say that, the debug view that I said would open automatically, if you click this button over here, it will open up debug view. It's quite a useful view if you want to use it, but I don't really use it that much. It's not too much of a big deal if you don't end up using it. Anyway, so first things first is how to create a new project. Now if you've got a different thing, if you're not using Eclipse, you won't be able to do it in this way. It might be a little bit different for you, but the idea is pretty much the same. You need to create a new project in Eclipse. That means going over here to that drop down, clicking it, and then clicking on Java project. Then you will name your project, and I'm going to name this one Java Tutorial 1 or 01. There's no problem with spaces. You don't really need to worry about how you write it, just as long as you remember that's the name of the project. Then you can go ahead and click finish. Now you've got a project, and it's going to include Jerry system library. That's just stuff that's there because you're using Java 8, or in my case I'm using Java 8. Yours might be different. So what you do now is you click on the actual package, and you can either create a class straight in here and start coding. What a class is basically just a file for coding, and in Java the extension for a class will be .java, and you'll also see a .class. If you don't understand what that .class is for, that's basically just a compiled version or semi-compiled version of the Java file that you've created. And the Java file is where you're going to code all your stuff. So I usually like to put a package. A package is simply a folder, just a little folder that you can put your code in. That way when you have more code that we'll eventually get to, your code can be placed into different folders, and it can be placed in a nice, neat way that you can kind of put all code that's related to each other in a specific folder, and then all code that's related to something else in a specific other folder, and you can just organize it like that. I just suggest starting out with creating a package. Now this package doesn't really mean much, there's no point to it, so I'm just going to call it the main package. Or you can even use the conventional name, which is my something, whatever it is you want to use, but I'm just going to call it main and create. So now that you've got a package, that's basically just a folder, and that's how the folder is going to show up. All you have to do now is click on the folder, so that it automatically knows to put it in there, because if you don't, and you click here, which is new Java class, and that's for a new package, if you click on the new Java class, and you haven't highlighted this in there, sometimes it won't pick up the correct package. It happened to pick up the correct package this time, but if it doesn't, you just simply need to click on Browse and click the one that matches your one. Default package basically means don't put it in any folder, just put it straight in there, which is a little bit of a mess, which is why I prefer it like this. Anyway, so now you've got the package, the name of the source folder, which is our project, and the name. This name over here is going to be the name of the actual class, which is going to be your little coding file. I'm going to call it main, and I'll explain why a little bit later on in some of the later tutorials. And then we're going to tick this over here. Unless you want to write that manually, you can, but considering this thing automatically generates that, you don't really have to. And don't worry about this or any of the other things. Basically just put the name in over here, make sure it's the right package, which is this one. And yeah, the name, and then don't worry about that, don't worry about this. Tick this one and keep this one ticked, and then you can click on finish and it will create your new class. Now it pops up over here, and if it doesn't, for whatever reason, you can always just go and double click it and it will open up over there. And this is where we're going to start coding. So I'm just going to say code goes here, and there's three parts to this. Number one, package, the package statement over here, where you can see that it starts. That's just to say which package it is in other words, a folder. And the folder starts out from this source folder. In other words, you'll say main, and if there's a folder inside this folder, which in order to do that you'd have to do it like this basically, main dot other folder or inside folder. And now we'll make it so that the inside folder will be inside the main folder, and that's kind of how you state it. It's kind of just a dot over here to say inside. So basically you have main is your folder over here. Inside folder will be a folder that is inside the main, and the only way to show that that folder is supposed to be inside the main folder is with this dot over here in between them. Then you can also do dot inside folder 2, and then that way you can say that there's a main folder. Inside that folder there's a folder called inside folder, and inside that folder there's another folder called inside folder 2. But we're not going to mess with that for now. So what we're going to do is just going to go back to the main, and now I've explained what the package is. Basically, if we were to create the inside folder, then we'd be doing it like this. If this was inside that inside folder and not inside the main. But because it's inside the main, we're working from this folder. So although it may make sense to say main, if there's a folder inside main, like inside folder, like the one that I was showing earlier, you could just say inside folder over here. But that doesn't actually work. You actually need to state it from the original folder, from the starting folder. And main would be the starting folder, so you have to say main dot. But because there's no folder inside that one, I'm just going to keep going with the start of the tutorial. I feel like I've explained enough of the beginning. If anyone has any question, feel free to leave any comments, even suggestions, anything like that. I don't really mind seeing any of that. I will read through the comments if I see anything. And basically what I'm going to start here with is the very start of the code. So I'll start with this one. This is where the code actually starts. So the first part of it, where it says package main, is just a package. That's just a folder that it's inside. Next one is public class. Public class, basically, don't worry about the word public yet. We will get to what those mean. Don't worry about the word static either. We'll get to what that means. And void, don't worry about that either. We'll get to that. For now, just remember class and then name the class. This basically says we are inside a class called main. And this right here needs to match the name over here. So main.java means that class is main. You don't say main.java. There's no .java on this part. It's just main. Now inside this you'll see, if you tick the generate this code, it will generate this thing over here. Now this is the main method. This method is basically a part of the code that runs when you open the program. That's all you need to know so far. I'll get into more detail in future tutorials and stuff like that, and more information on this later. So I'll get to one other thing. You may be seeing these curly brackets over here. Now curly brackets basically means this is happening inside this. Curly brackets are a way to say public class main contains all the things inside these curly brackets, between these ones. Now be careful, because there's another curly bracket over here, so you might start to think that this curly bracket matches up with this curly bracket, but in reality it's this curly bracket that matches up with this curly bracket, and this curly bracket matches up with this one over here. And you'll see Eclipse automatically kind of gives a little box around it to show which ones matches which one. And if you hover over the last bracket, it also shows you the actual code block, like this, which isn't really useful right now because we don't have any code inside, so we don't really need to see the start of the code block. But it can be useful when you have a lot of code and then it kind of extends past the screen and you just want to see which method this belongs to, or which block this belongs to. Basically anything in between a starting bracket and an ending curly bracket is called a block of code, and anything between that is just its own block. Anything within that, there can be another block within that and another block within that one, and there's no end to how many blocks can be within each other. Now we need to start by coding inside this method, as you can see in between these curly brackets, and just make sure that you code in the right place, because if you don't, it won't work. What we're going to start with now is data types. Now the biggest part to programming is you need to be able to store information. You need to be able to store information for use later, or even just to store information for the next time you run the program. A great way to store information within a run is to simply create what is called a variable. I'm just going to put the word right there. That's not actually the word you're going to write. That's a variable. So variables have different data types, different information that can be stored within them. Certain variables can store characters, certain variables can store numbers, certain variables can store numbers with decimal points and stuff like that. What we're going to do now is I'm going to start by showing 8 different variable types that you're going to be using the most, or rather the primitive data types. And just so this thing doesn't give me errors, you can put 2 forward slashes. That's called a comment, and those comments are for you. Leave them above pieces of code to explain to yourself in the future what this code means. Just give yourself little notes so you can kind of understand what this code does. That's what a comment is basically used for. So put 2 forward slashes and then write what your next piece of code is doing. That way you can look at it in the future if you forgot what it did, without having to go through the code yourself and trying to figure it out. So I'm going to start from smallest to biggest. I'm going to start with a single bit, a Boolean, which is basically a true or false value. And by the way, I'm using Control S to save. That's going to be a very useful combination of keys that you're going to need. Another one, if you're using Eclipse, is Control A, then use Control plus I, which is indentation, basically. So those are basically the key combinations that you're gonna use the most here. Control S, and then for indentation, Control A plus I. Basically, you can write it like this. Java doesn't really care about any kind of indentation, doesn't care that one thing's in front of another, doesn't care that it's like this, or that it's like that, or whatever it is. But it does get a little bit annoying to work with it when it's like this. So instead of doing that, what you should do is just press Control A, Control I, and then it auto indents for you. So Boolean, which is simply a true or false value, I'm going to call it a choice, and I'm going to give it the value true. Another option is false. You could just as easily put the word false here instead of true. It means the same thing. Just remember when you do comments that they only span one line, so as soon as you press enter they stop going into effect. And it doesn't matter if you put any code here, it actually won't run, so you can use that to comment out code and make it not run for now whilst you find some kind of bug or something like that. It could be very useful. And next we're going to go through, I'm going to actually put them really quickly. Boolean, byte, char, short, short, and then char, and then int, float, long, and double. Some of them don't really have to be in this order because, well, firstly, Boolean doesn't actually technically take 1 bit, even though I did say 1 bit when I started out. And 1 bit, basically in computer systems, everything is being stored as a 1 or a 0, in other words, electricity or no electricity. And those numbers are just being interpreted in different ways. In case of a Boolean, a 1 is interpreted as being true, and a 0 is interpreted as being false. But for some reason, you won't be able to use 1. It does work in some other languages, but in Java that's not really an option. Right, so you can't use 1 or 0, even though that's technically what it means, the true or false. I guess that's just to make it a little bit easier to understand when you code. Then byte, which is 8 bits. 8 bits is basically this much data. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits. And there can be ones in any one of these. There's ones sometimes, ones here, there. The ones simply mean simply give it a value of what it actually means. So in case of a byte, you've got 8 of those, and those 8 will give it a value that you can store. That's basically the size of a single memory location in RAM. In case you're interested in that, you can go and research more into it. If you want to know more, you can leave a comment asking for it, and I can even make a video explaining how it all works, kind of a introductory to storing data in a computer. Anyway, so byte, I'm just going to call it A because I don't want to think of any creative names. Alright, so these are the names I'm going to give it. Byte, I'm going to put 145, and then cast it into a byte. I will explain that a little bit later on. Short can be saved like this data type. There we go. Short can be written like this, simply just as easily as byte can be written without a problem. Then we've got char. Char is short for the word character, right? And in order to write a character, you need these single quotation marks, put 2 single quotation marks, and Java and Eclipse will automatically add the second one for you sometimes. And you can only write 1 character inside there. You can't write 2 characters. It doesn't store that. It only stores 1 character, 1 letter of any type. Anyway, for short, you actually don't need to write short. I was wondering why it gave me an error. It turned out I just didn't save, and it didn't recognize that I actually stored a value that was allowed. Alright, next, so we've gone through char. Char is just a single letter. And in order to write a string of letters, like a word or a sentence, you would need what is called a string. But I will show that later on. And I'll explain why it's not part of the 8 primitive types. So what I'm going to write now is, I've given you an int. Basically, int is just short for integer. I'll just write integer. In other words, a number that doesn't have a decimal point. Float is a floating point value. That may be a new term to some of you. And basically what a floating point value is, basically a value with a decimal point, but not as accurate as a double. That's why you'll see later on when we get to double why it's useful to use that as well. So you can put 234.12 like this. And what I wanted to explain is this thing over here. When you put a decimal point, it by default assumes it's a double. So in order to tell Java that it's not a double, or it's not being used as a double in this case, you will simply have to put a single character F at the end of it. You can put a capital F if you want, you can put a small f, it doesn't matter. Just don't put 2 F's, because that won't work. So capital or small letter doesn't really matter. Just leaving a little note here, F or F, same thing. And for long, you basically do the same thing. And once again, like I said, when you use this number over here, you can easily store it inside a long, because it's actually a bigger number. But the thing is, you won't be able to use this number, or even that number, over here, because once again, the same problem as this one, it assumes it's an integer when you use a number that's like this. So what you need to do is tell Java it's not going to be treated as an integer by putting either capital letter L or a small letter L. And for double is simply the number you're going to put in there, and you don't have to specify anything, because double is the default way that Java treats any decimal point number, unless you specify otherwise. And when you don't have a decimal point, int is the default way it's going to treat it. So that's basically it for these primitive types. One extra thing that I'm going to get to is, if you put a backslash, this one over here, backslash, it will actually give an error, because in Java, backslash is being used to create special characters. You can use backslash n, and that means next line. You can use backslash t, and that means tab space, and quite a lot of the backslashes. But if you don't want the backslash to be treated as an escape character, and therefore cause it, and that's what it is, by the way, an escape character, that's what they call it, and cause an error, you can just put 2 of them, and the first one will say it's an escape character, the second one will say it's just this character being escaped. So basically just ignore the escape character and put a single backslash, and that will basically just be a single backslash. That's what it means. So I'm just going to leave it like that and go ahead into the next part. So I said I was going to talk about strings. Right? First, I want to go through the sizes, because that's actually quite important for some of you. What I'm going to do is I'm just going to put a little bit of tab spaces so I can put the sizes over here. The size of this is 8 bits, but it only uses 1 bit out of those 8 bits, which is a little bit of waste, but unfortunately that's just how it works. This over here is 8 bits, and it uses 8 bits, which is why I'm not going to leave any comment over here. Short is a 16-bit number, 16 bits. Then a char is also 16 bits, which some people don't like, by the way. That basically means UTF-16, if you want to go ahead and research why that is the case, that it uses 16 bits. For example, C++ actually uses 8 bits over here. Then int is a 32-bit number. A float is another 32 bits. Long is a 64-bit number. And a double is a 64-bit number again. So all these are basically just ones or zeros. They're numerical values that can be interpreted differently depending on what the data type is. In other words, a short will be interpreted as a number. A char will interpret the number as being a character, and each character has a value called ASCII value. And yeah, basically that's how it's going to work. Each one has a different amount of bits, and remember this is 8 bits. Each bit is a single 1 or 0. So you can see these are 8 bits. And then these ones have 64 bits. Now for every single bit you add on, you basically have times 2 the amount of numbers you can represent with it. So basically for a 64-bit number, let me just show you quickly. For a 64-bit number, you can represent 2 to the power of 64, and that's the biggest number you can put into there, which is a huge number, as you can see, times 10 to the power of 19. For 8 bits, you can put 8 bits of data, 2 to the power of 8 numbers are possible to be represented. And since it starts with a 0, the highest number that can actually be represented is this number. So basically it counts from 0. So 1 is 2, 2 is the third number, 3 is the fourth number, and so on and so forth. 255 is therefore the 256th number, and 0 being the first number, which is not natural for most people. Most people count from 1. But that's how Java does it, and quite a lot of other programming languages as well, with the exception of perhaps Fortran and maybe a few others, but that's not really relevant. Anyway, that's the highest number you can represent in an 8-bit number. And then 2 to the power of 16 is how much you can represent, how many numbers you can represent in 16 bits, and so on and so forth. So for every bit you add, you can represent 2 times the numbers of the previous. So 17 bits would be able to represent this much, 18 bits would be able to represent that much, and so on and so forth. That's why I use 2 to the power of, to shorten the process of figuring out how many numbers can be represented. So basically I'm just going to leave it over here if you want to know. If you don't want to know, that's fine, you can always go back to this tutorial. It really doesn't matter too much until you get into the more extreme stuff where you actually need to conserve space and be a little bit more efficient. Once again, if you really want efficiency, you should probably wait for my C++ tutorials, but we'll get to that, and this is perfectly fine to use. I'll explain a little bit on why it's not as efficient when we get into probably tutorial 5, I think, if I don't change my mind about the numbering. Anyway, so let's get into string. Now, string is a non-primitive type, and as you can see, string is the same value that's over here, but I'll explain what this means later on. Basically, string is a bunch of characters put side by side. So a string can represent a word or a sentence or a paragraph. of data. And this is kind of how you create it. So a string, and I'm going to call it H. I know, not very creative, but let me just call it H, and we can get on with it for now. And this is how you're going to use it. So you need, for a string, unlike a char, you actually need quotation marks like that in order to create them. And now what we're going to do is we're going to write Java tutorial 01. And that's the word we have over here. And note that these ones are single quotation marks, unlike these ones. String is a double quotation mark one, and char is the one where you use a single quotation mark. That's how you can remember it. And what we do now is every single one of these characters is technically being saved as a char, but it's not being shown to you like that. So you can basically just, instead of creating a char for every single one of these characters, or an array, as I'll actually get to in a bit, we can just go ahead and type all these, and it will automatically create an array of these characters, like a list of these characters, one after the other. And it will be represented in this way for people that want to read it. Next, I want to go ahead and go into arrays. Now, before I go into arrays, I want to just go back here and say this is not a primitive data type. As you can see, it's not being highlighted in purple, so it kind of doesn't. So this doesn't actually act like a primitive, but in a way it can still kind of be used like one, because you can still use it as you would a normal primitive. Just put in the data like this. Next, I want to go into arrays. There are quite a lot of different types of arrays, but I'm only going to go over basic arrays, standard arrays. I'm going to show one example of it. I'm not going to go through every 8 primitive types and the string. I can just tell you already that in order to do this, all you have to do is just copy and paste and create it the same way. So you would normally create an integer like this, int something equals some value, like 12. Now what happens when you want to store a whole bunch of different values, but you don't want to create an integer for every single one of those values, and instead just want to have one value that you can just refer to, and then refer to the other ones by a number, an index. So basically what you can do is, instead of creating int something 1, int something 2, like this, and having to name each one of these something different, delete all of these, add these square brackets, open and close square brackets, equals, and then on this side you're going to use the word new, and then the data type that you used over here. In other words, in this case it's new int because it's an int, and then you end it with square brackets, just like over here. Now you see it still gives you an error, and that is because in Java, and this is not how it works in JavaScript. If you've ever coded in JavaScript, you actually have to specify in Java how big the actual array is. In JavaScript, you can leave it to the interpreter to automatically resize it as it needs to. But in Java, you actually need to specify from the very start what the size of it is. So you start with a value, like new int, size 10, which means there are 10 different numbers that can be placed into this. That way we don't have to create 10 different variables in order to store these 10 different values. Now, in order to write into them, you'd simply do something at position, and we start from 0 as the first number, and then we're going to give it a value like 12. Right? For now, this will still seem annoying to work with, because you're going to still have to do this. But you'll see later on, when we get into more complex code, that this actually simplifies the process. Currently I just don't want to show any more advanced code because I don't think it's quite a good idea to go that far yet in the first tutorial, even though I've already explained what an array is. But basically arrays are just a single value that can be capable of storing however many values that you want. Of course, the limitation is memory and the amount of numbers you can put in an integer. Remember, that's 32 bits of data. But that's not really important right now. Anyway, what you can see is I started from 0. I said something at position, basically. These brackets mean at position. 0 equals 12, 13, 14, 15, 16, 17. I'm just going to change these values. Like this. There we go. And as you can see, I use the value 0. I said 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't have any value for 10. And the reason for that is because there are 10 of them. And if you count from 0, then 0 is 1. 1 is the second number. 2 is the third number. 3 is the fourth number. 5th number, 6th number, 7th number, 8, 9, and 10. So there are 10 different numbers being stored over here. As you can see, 10 different lines. Which is why it gets confusing to some people who start with coding, because they're not really used from starting from 0, but if you think about it as starting from 0, it will just get a little bit of time, it will take a little bit of time to get used to, and then once you get used to it, it will help you with a lot of other programming languages. Most programming languages, at least so as far as I know, use a 0 index. So this is definitely a good idea to remember to be able to use an index that you can start from, because unfortunately that's how most languages work. So this is basically how you store 10 different numbers inside a single array. Now you can't do this with an integer unless you've specified these square brackets, so remember the square brackets. Also remember the word new. And I'll get into what the word new means later as we get into more complex code. But for now, this is as far as I want to explain. You can go over this, try to use it. I suggest using this because it's always a good idea. And then one more thing. Sometimes you want a certain value and you don't want it to be able to change. For example, if you want to have a value like pi, right? And the value is 3.14, right? So this is how much I'm going to write. Obviously, I'm going to use a float for this one, even though you don't need to. Alright, and that's basically how I decided to save it. Now the problem is, if I ever say pi equals to 3, it will now change what the value of pi was before. And this isn't really intended behavior, because sometimes you just want a value that will stay like that for the rest of the program. So you can create a value that stays like that for the rest of the program and cannot change by writing the word final. That way it can never change what the value was. So now what's going to happen is if I say pi equals to 3, you're going to see it gives me a red underline and it says final local variable pi cannot be assigned. That's basically what final means. It's not capable of being changed. A good thing you can do that I'm going to actually note over here as extra is if you create a little integer value and you give it the value of 34, for example, you can easily change the value through a calculation. So if you say value equals value plus 2, that will basically save what the value was, 34, plus 2, into this over here. So now you've changed value from 34 into 36. But that's as far as I'm going to go in this tutorial, because I think I want to leave a little bit of stuff that I can teach in the next tutorial. So I hope everyone that watched this understands what's going on. If not, you can leave a comment and I'll gladly help. And the best thing I can suggest is just simply go over this and try. Just use this even if you don't know if it's going to work or not. In this tutorial we'll start getting into more useful things that you can do with the language, because just saving variables is not very useful. It's just one thing that a computer can do, is save. We still need to get into the calculation part of it, how a computer can calculate and decide on things to do. And that's going to be the end of this tutorial. See you in the next tutorial.